Launched in 2013, the European Space Agency's Gaia mission is building the biggest and most accurate 3D space catalog ever made, which maps out over 1 billion astronomical objects and provides an unprecedented understanding of our place in space. So whether you're a professional space explorer or a backyard observer, this new catalog promises to be a star chart like no other. I'm pleased today to be speaking with Timo Prusti. He is a Gaia project scientist at the European Space Agency. Thank you so much, Timo, for joining us.
Thanks. It's a pleasure to join you.
Well, throughout human history, we've always been a species that has wanted to explore and understand our surroundings, see what's over the next horizon. I really feel like the Gaia mission has taken this to a pretty unprecedented level. I just want to start, if you could just describe what Gaia is and what are some of the objectives of this mission?
So Gaia is a billion star mapper of doing mainly our Milky Way. And it really is the requirements for the mission have been set in order to understand our home galaxy, the Milky Way, better. So that is set how Gaia is actually working and what it is measuring. But then it turns out that it's really useful for many, many other things because what we need for the Milky Way are very fundamental measurements.
Could you sort of go over what the main ways that scientists are using this data to kind of discover new insights about the galaxy and the universe in general?
So the important thing in Gaia is what we call astrometry. So this is actually a very ancient way to do astronomy. It's basically measuring the positions of stars. However, it's not only to understand where the stars are in the sky, but measuring them very precisely gives us information also of their distances and movements. And that's really the key thing what Gaia is doing and why it has to be done from space, because all these movements are extremely tiny and you have to be extremely stable to do any of these things.
Yeah, on that point, Gaia is located out in the Sun-Earth Lagrange 2 point. Why does it have to be out there and where is that in relation to Earth?
So if you start from the sun, first look where Earth is. Earth is 150 million kilometers from the sun. And this Lagrange second point is 1.5 million kilometers from Earth to the other direction, so away from the sun. It is actually beyond the moon. And that is the whole thing why it is interesting for astronomical measurements, because if we look from that point towards the sun, we will see the sun, the Earth, and the moon roughly in the same direction. So if we put a big shade, what Gaia is doing, putting a big shade to blocking that light, then we have the whole dark universe at the other direction. And that's the art of L2 point.
So you're able to basically block out all of the kind of sunlight and all of the disruptive stuff and just see this massive galaxy and universe beyond.
That is exactly the idea, that we have free view to the dark sky.
I'm seeing this amazing skyscape behind you here, wonderful catalog of stars. Is that a Gaia image? And if so, what is it?
So this is indeed the number of stars one sees in a certain part of the sky. So it is definitely Gaia results. And of course, there is a personal choice here that if I can put a little bit, you see the black spots. So those are chameleon clouds in the southern sky. And that's the area where I did my thesis a long time ago.
From my perspective as a space reporter, every single time there's one of these big data release projects from Gaia, I think there's been two and like a little bit half of one, like an early data release of a third. It's like Christmas and New Year's and every holiday you can imagine for astronomers, right? Like you get this glut of papers that starts appearing like a couple months afterwards with everyone trolling through all the new data. So could you just explain what's been in the two full data releases that have happened so far and what we can expect from the full third and fourth release?
Before Gaia, we roughly had a map of the city where we lived. But then everything beyond that was a little bit unclear and gray. And what Gaia is doing actually, we are not mapping just a state or a country, but we are mapping a continent. So we are just making this huge leap from our surroundings of our sun to really a large fraction of our Milky Way galaxy.
And even beyond the astronomical community, if the public wanted to look at this data, would they be able to try to educate themselves on the kind of data that's coming back from Gaia? Is it that open?
It is totally open, so anyone can use it. And we have actually, we are following the people who are using the data, and we get help desk questions. And there are teachers who are making cases for their students at schools. So it is definitely used not only by the hardcore scientists, but also by the wider audience.
That's really wonderful to know that, it has this public effect as well, because it is, it's a mission that is helping us understand where our place in things, and that affects everybody. To that point, you mentioned this is primarily a mission that's focused on our own galaxy, but does it ever look at stuff that's extragalactic? Are there objects that Gaia is mapping that are in other galaxies or out really distant space?
By far, most of the billion objects what we are observing are stars in our own Milky Way galaxy. But then you go really to the extremes. So we also see asteroids in our own solar system. It's only a few 100,000. So compared to the billion, it's nothing. But we get it will be the biggest database of measurements of asteroids. We also see galaxies which are far away. So in the next release, we will have a few million galaxies, and the properties of those ones will be published. And if one goes to stars, actually in the galaxies which are close by our Milky Way galaxy, some stars are bright enough to be seen by Gaia. So there are also a few million stars in galaxies around us, the brightest ones of those galaxies, which will be also in the catalog.
That's really exciting. Wow, those must be incredibly luminous objects to be shining across intergalactic space.
Correct. They are really the most massive stars, the brightest ones.
So Gaia was launched in 2013. It's been doing all of these amazing data releases. What's the sort of long-term future of the mission? Is there a mission end date? And when will it know as a project that it's done?
Well, we are a project with actually an end date, and this is coming from the fact that when we are observing, we are spinning the satellite. And you can imagine if you try to make a very sharp image while spinning, everyone who has done photography says that you should not move when you are making a sharp photograph. So we are doing that, and we are doing it by controlling the spin extremely precisely. And we are moving at the same time the picture on our camera. So that might be a little bit difficult to imagine how it works, but we are actually making a picture while moving, but we are moving the picture at the same speed on the detector as Gaia is spinning. But that works only if the spin is controlled really precisely. And for that one, we need something what we call cold gas. So there is a tank, and we are making tiny little puffs of gas to get the spin precise. And at some point that gas, we will run out of it, and the predicted time when we will run out of it is early 25. So we really hope that nothing else happens before 25, so that we can get more than 10 years of Gaia data.
Certainly, whenever I report on Gaia data, it really kind of boggles my mind how broad the insights are from so many different fields. I love the kind of insights about these hypervelocity stars that shoot across space and what's going on at the center of the galaxy. What do you think are some of the most exciting discoveries that have been made so far, in your opinion? And what else do you think you are looking forward to along those same lines?
So I think maybe one of the important things what should be mentioned is that one of the reasons why we have the Gaia mission is we try to understand better our own Milky Way, the structure, and also the evolution of it. And what was one of the results came out is that we see some big impact which our Milky Way had some 10 billion years ago. And how can we know that there was a big impact? Because the Gaia data revealed that there is quite a bunch of stars which are actually orbiting our Milky Way to the wrong direction. So meaning that they go to the opposite direction as most of the stars. And the only explanation of this one is that 10 billion years ago, the Milky Way was cannibalizing a small galaxy, which hit our Milky Way against the rotation. And so the stars were captured by our Milky Way, but they still remember where they came from because there is nothing to stop them. So they still circle the galactic center at the wrong direction after 10 billion years. And you can only tell this one because the Gaia provides the movement in that level of accuracy. So it really demonstrates that the idea of measuring the motions of stars in order to understand our Milky Way, it works. We really understand now much better what has happened in the past, how our Milky Way has been constructed.
That actually touches on two of my favorite space terms, galactic cannibalism and also galactic archaeology. I think has some relevance there too, where being able to kind of find these signs of what the galaxy has been through in the past. I mean, it's just astonishing to think that our galaxy has been eating other galaxies and what that means. Can you tell me a little bit more about how that plays into our wider understanding of how galaxies evolve even beyond the Milky Way?
So this was always the big issue, that when we looked at the other galaxies, extragalactic sky, we could see all the signs that smaller galaxies are being cannibalized by the big ones. So that's the build-up of bigger and bigger galaxies. But our picture of our own Milky Way was simply because we are inside it. It's very difficult to see it when you are inside something. And we were lacking the information that, do we see the similar kind of signs in our Milky Way galaxy? And now Gaia data is really demonstrating that, yes, exactly. We see the remnants of this 10 billion years ago event. But we see also now there are further articles coming out where people see signatures of other galaxies which have been merged to our Milky Way galaxy. So in a way, we are showing that our Milky Way, how it is building up, it fits into the big general picture, how we think galaxies form, where the big guys are eating the small guys.
That's so wild. I love it. And I don't know. I mean, I know that there's not a huge amount, I think, of disruption on the stellar solar system level when these things happen. But I'm still glad to be in the big galaxy that's eating other galaxies rather than the small one.
Well, watch out, because we might be eaten by the Andromeda galaxy in the future.
Okay. Well, if I live 5 billion years, then
Exactly.
I'll watch out for that.